Good evening, my friend. As the world outside settles into quiet, let yourself do the same. Find a comfortable place to rest. Feel the weight leave your shoulders and notice your breath moving in and out, slow and easy. You are safe here, wrapped in the hush of night and the steady rhythm of your own heartbeat. Tonight, we'll drift together through something close to home, yet endlessly vast, the Milky Way. For so long, we could only imagine its true size, catching glimpses between clouds of dust and light. But now, we can finally trace its graceful shape, the far edges where starlight fades, and the place our little sun calls home within that grand spiral sea. There's no need to hurry. Just let each idea arrive like a calm wave, carrying you deeper into rest. And if this quiet journey brings you peace, you might gently like and subscribe. It helps others find their way here too. For now, let's begin our slow journey across the galaxy we call home. Somewhere far above the roof and the trees, beyond the last street lamp and the last cloud, you are already in motion, gently, steadily sailing through space at well over 500,000 miles an hour. Not racing, not straining, just drifting with the great wheel we live inside. A spiral island of hundreds of billions of suns, so wide that light itself needs about 100,000 years to cross from one side to the other. We call this island the Milky Way, though none of us has ever stepped outside it to see the full sweep. We live within the pattern we're trying to picture, like a traveler tracing the outline of a forest while standing among its trees. Astronauts talk about the first time Earth reveals itself through a small window, how the familiar dissolves. From the ground, a city feels endless. Avenues and neighborhoods, bridges and river bends, a life spread out in known turns. From orbit, the glow of that city slips into a handful of scattered lights, then into a faint haze, and then it is gone. Streets and houses melt into the continent's larger curve. Mountains become gentle crumples of paper. Oceans turn to a single sheet of blue glass with sunlight skating across it. They look for their hometown, for a childhood park, for the roof that once thundered with rain. They cannot find it. From just a couple 100 miles up, a house, any house, disappears. Distance doesn't argue. It simply erases detail. Pulling back does this again and again. 1,000 miles higher, and whole states soften into silhouettes. 10,000 miles and continents blur, the planet rounding into a marble of cloud and water, white swirls and blue pulse, a single breath floating in darkness. The backyard that felt like a world becomes a fleck on that marble. The marble itself becomes a bead when imagination keeps zooming, and the mind discovers a new kind of quiet, a hush made of scale. We shrink as we rise, and what surrounds us expands faster than we can hold in thought. The black between stars is not empty in the ordinary sense. It is generous with room, generous with silence. If Earth were a simple marble on your desk, just a small, smooth sphere, the nearest star would sit more than 4,000 miles away. Imagine that. A second marble on a different desk in another city, with a long, dark hallway of nothing between them. That is how lonely the distances are. There is no crowding in space the way there is at a market or a train station. The universe spreads out its furniture, leaves vast aisles between tables, and invites light to walk for years, to carry a message from one room to another. On our little marble is your chair, your breath, this very moment. Around it is a vacuum that does not press or hurry. Even so, we are not adrift without company. The marble rides a larger craft, a slow-turning river of stars and worlds and dust, where each sparkle is a sun, Each sun has its own family, and each family sings in orbits you could hum if patience were long enough. This is the galaxy we belong to. We are inside its sleeve, counting threads by touch, learning the pattern by the way starlight brushes our eyes. Light is our courier in this learning, and light has a rhythm. The glow from Proxima Centauri, the nearest star after the Sun, takes more than 4 years to arrive. 4 winters, 4 springs, a handful of birthdays and quiet afternoons, and only then do those thin, persistent photons complete their journey, step over the threshold of your pupil, and lay their story down on the retina, like a letter finally delivered. The light in your room is young, chattering. The light from the hallway star is older, patient, almost shy. Much farther out, light sets off on journeys so long that it crosses millions of years, even tens of millions, and the universe changes while it travels, as if the scenery redraws itself between each step. Think for a moment about miles the way sailors once did, not as numbers, but as moods. A voyage of 4,000 miles once felt like a boundary maps thinned. Monsters curled in the margins. Winds grew uncertain. That was a kind of courage, to lean into the blankness. Now, imagine 25 trillion miles. The nearest star after the Sun is that far from us, and the mind wobbles. It is all right to let it wobble. If a car could drive without stopping, day and night, year after year, 40 million years would pass before you parked in the star's glow. The scale does not scold. It simply asks us to breathe a little more slowly and let the ideas settle like dusk over a quiet field. Once that calm is there, a different clarity arrives. The pinpricks above your roof are not pinpricks, they are furnaces, each one a colossal engine fusing light from the bones of matter, each with storms and flares and winds that could lift whole worlds. They only look tiny because distance softens their edges, the way mountains do from a great height. The weakness is not in your eyes, but in the logic of space, which trades detail for overview. To know the whole, we often give up the close. We are surrounded by these distant suns, hundreds of billions within our own galaxy, scattered like frost through the spiral arms and tucked into the halo, sprinkled in clusters, drifting in streams that are the ghost ribbons of older galaxies long since swallowed. Some of their light left before there were people to name the constellations. Some left before there were whales to lace song through the oceans. Some left before forests learned to breathe our air. Looking up at night is a kind of time travel, an easy, quiet kind where you do not move at all, and yet the past arrives to sit beside you. There is a tenderness to this, because we can never step outside and see the Milky Way as it is, entire and present in one glance. We are like ants feeling the brass of a clock from within its housing, hearing the soft tick, finding teeth on a gear, guessing the curve by the way our path bends. We sketch the face by how the hands sweep our lives. We are not thwarted by this. We are guided. Each measurement is a touch. Each touch is a note in a longer song. The galaxy itself carries us, all of us, in a wide circle that takes something like 200 million years to complete, as if a season in the Milky Way is older than civilization. We orbit the center where a heavy, dark presence, calm and compact, keeps time, while star after star joins the dance. The speed sounds fierce if you count miles per hour, yet from where you sit, it is as gentle as breathing. We are passengers who never feel the rails, sailors who never hear the keel cut water. Distances keep teaching. A star 4 light years away is close, a neighbor across the lane. A star 50,000 light-years away, the far side of our disk, is family across an ocean. Between them is space as soft as velvet in imagination and as strict as numbers in a table. Both are true. The velvet you rest in tonight, and the math that lets us lay a ruler across the dark and whisper how wide home is. When you go out on a clear night, and the Milky Way arches overhead like a river of salt on black stone, you're seeing a thin cross-section of the disk from within, edge on, the way a swimmer sees the river as a band of current rather than a wide flood. The smear is our arm, busy with clusters and clouds. The darkness inside it is dust, quiet but assertive, hiding what lies behind. Telescopes peel some of that gauze away, like lifting fine lace from a window. Radio waves and infrared glow slip through the dust and carry news of the far bank. And slowly, year by year, picture by patient picture, the shorelines of our home become clearer. Yet there is mercy in what remains unknown. Not everything must be pinned to a board. The galaxy is not a specimen, it is a night-long conversation. We listen to stars pulse, count the rhythm, turn those beats into distances, and then into a map. We notice streams of stars flowing in strange angles, learn they are the rivers left from small galaxies, pulled apart and folded in. We measure the way outer stars move and realize there is more mass than we can see, an invisible scaffold, dark matter, cradling the disk and holding its whorl together. The picture grows, and with it, our sense of where we sit, not at the center, not at the edge, but in a luminous neighborhood on a mid-range spiral arm, one garden among many. Some of the light, now arriving, began its trip when no human eyes existed to receive it. That is a beautiful thought, not sad, not lonely, because it means the universe has always had patience. It keeps appointments across time no creature's lifetime could hold. You are part of one such appointment tonight, letting the day unlace while the oldest stories spill quietly into the room through starlight that has crossed gulfs without hurry and found you at last. Let your shoulders sink a little deeper. Hear the faint hum of night, the refrigerator's distant purr, a car's soft passing, the breath of someone sleeping in the next room, and imagine those sounds as the local music of a place inside a vast, slow-turning symphony. You do not need to see the whole orchestra to know the melody. A handful of notes is enough. The galaxy's edge is far, its center older than every story we tell, and still, the part you hold is real. A chair, a window, a sliver of sky, a mind that can feel the scale and not be crushed by it. We are tiny not in the way of being less, but in the way of being held one small warmth inside a great room. The Milky Way is wide enough for 100,000 years of light to cross, yet it makes space for the smallest comforts. A cup cooling on a table, the weight of a blanket, a heartbeat counting time more softly than any clock. Every number that once felt sharp, miles and years, speeds and spans, can set its edges down now and become part of a calmer picture. You are on a quiet ride through a luminous archipelago, carried by a spiral that doesn't rush your sleep. And somewhere beyond the roof, beyond the careful frame of the window, the galaxy keeps turning, stars threading their long paths, light setting out and arriving, distances teaching their gentle lesson. Step back and the small vanishes. Step forward and the vast dissolves. Hold still, and both can live together for a while. In that stillness, the Milky Way is not a diagram or a number. It is a feeling of room to breathe, of time to drift, of home spread wide as night. If you could see the night with the patience of light itself, you would find that some of the starlight reaching your eyes tonight began its journey when mammoths still walked the plains and glaciers ruled the north. The glow from the far edge of our galaxy has been crossing the darkness for 100,000 years, traveling unbothered through storms of dust, through the rise and fall of civilizations, through every breath that has ever filled a pair of human lungs. What you see as a faint mist in the Milky Way's band is ancient news still on its way home. Each photon carries a memory from a place so distant it might as well belong to another universe entirely. Now, picture this, something small, something you can hold, a single grain of sand resting between your fingertips. It presses so lightly, you might not feel it at all. Tilt your hand, and it could vanish into the air. That little speck is about 1 millimeter across, easy to lose, easy to forget. Yet in our imagination, let it stand for something much larger. Let it be Earth itself, oceans and mountains, clouds and cities, forests breathing through the seasons, every human who ever was, all of it, all history, all laughter, compressed into that single grain. Hold the world as dust and feel how delicate it becomes. On this gentle scale, the vastness begins to whisper its lesson. The moon would be no more than a small pebble floating about 20 feet away, a pale companion gliding just at the edge of reach. The sun swells into a bright beach ball sitting half a mile down the road, its warmth no longer fierce but patient, as if it shines through fog. And Jupiter, our mighty giant, lord of storms and moons, turns into a smooth marble, rolling quietly 3 miles from where you stand. A walkable distance, yet on this scale, it already feels remote, tucked in its own orbit of silence. Keep shrinking yourself into this model, and now look for our next star, Proxima Centauri. You would need to travel 125,000 miles, half the distance from Earth to the Moon just to reach it. A journey across deserts and oceans and continents in a universe made of sand. You could not drive there. You could not fly there in any plane the human mind has built. You would need a rocket that could sail through emptiness without roads, without wind, guided only by mathematics and the stubborn faith that something awaits across the dark. When you imagine this sand-grain Earth floating beside its distant neighbors, something quiet but vast begins to take hold. You start to sense how small our solar system truly is. Even though the planets spin across millions of miles, they cluster close compared to the emptiness beyond. In our tiny model, the entire solar system fits comfortably within a circle 10 miles wide, small enough to stroll across in an afternoon if you didn't stop for lunch. Yet the next nearest solar system waits 125,000 miles away, 12,000 times farther than the width of our own family of worlds. Between one sun and the next, space opens its arms and fills them with nothing. This kind of emptiness isn't cruel, it's serene. The universe doesn't push us apart, it simply offers room, so much room that light itself must labor for years to carry messages from one warm spark to another. And still, somehow, those messages arrive. The Milky Way's stars call to one another across that void, their gravity weaving invisible threads that bind the great spiral together like a loom of time and dust. But even this model, strange and vast as it seems, barely grazes the true scope of our home. If we keep the same scale Earth as a grain of sand, the Milky Way would stretch about 11 billion miles from edge to edge. 11 billion miles. Light, which sprints through space at 670 million miles per hour, would still need 16 hours to race from one side to the other. Imagine driving that distance, not through country or continent, but through star fields in darkness, with the Milky Way's spiral arms rising like soft auroras on either side of you. The scale bends the mind, not by its coldness, but by its generosity. It reminds us how much universe there is to hold, even in thought. Yet numbers, once they grow too large, stop feeling like numbers. They dissolve into rhythm, into a hum you can almost hear if you listen between heartbeats. The hum of motion, of everything that moves even when it seems still. Because while you sit in your chair, wrapped in quiet, you are not motionless at all. You are moving faster than any spacecraft has ever dared. Start small again, the turning of the Earth. That spin alone carries you eastward at about 1,000 miles per hour. The planet's rotation is what paints sunrise and sunset across your window. Then add our orbit around the Sun, another 67,000 miles per hour. A grand looping circle that measures a year with every full term. You could stop there, and already your body would be a blur of motion through invisible geometry. But the dance goes deeper. The entire solar system, with its planets, moons, and belts of icy debris, sails together through space at nearly 560,000 miles per hour. That is not a poetic exaggeration. That is a fact woven into the night around you. Every breath you take, every thought you have, every dream that rises and fades as you sleep, all of it is happening aboard a vessel tearing through the cosmos at speeds that reduce our machines to toys. Think of the fastest jets, sleek and silver, cutting the air at 1,500 miles per hour. Think of the Concorde, once skimming the edge of the atmosphere, outracing sound itself at a little over 1,300. Even the great rockets that clawed free of Earth's pull, engines howling in white fire, reached only 25,000 miles per hour before the darkness accepted them. And still, the chair you sit in right now is gliding through the galaxy, more than 20 times faster than that. You do not feel it because speed is relative, and our senses belong to Earth's slow rhythms, the fall of rain, the turn of tides, the hush between breaths. Space, however, keeps its own tempo. At these cosmic speeds, everything becomes a gentle drift. There is no rush of wind, no roar of engines, no rattle of glass. Motion here is silent, patient, unending. The stars do not streak by like in the movies. They keep their places, each one fixed by distance, so immense that a lifetime cannot reveal the shift. Yet underneath that stillness, everything moves. The planets, the stars, the galaxy itself. It's as if the entire universe breathes, expanding and contracting in rhythms too slow for human eyes to notice. You are part of that breath. The atoms in your hands once belonged to stars that burned long before the sun existed, and one day they will drift out again to seed new worlds. The grain of sand that stands for Earth in your imagination is itself built of dust that has traveled across galactic distances, each speck carrying stories of collisions, explosions, and rebirths. Every step in the scale, model, every widening circle is not just a lesson in size, but in belonging. The spaces between things are not absences, they are the quiet, where everything connects. So, while you rest, remember, light is still traveling. From the far rim of the Milky Way, from the hearts of dying suns, from the faint glow of newborn stars still wrapped in dust, it streams endlessly toward you. The journey is long, 100,000 years, for some of it to arrive, but it does arrive. It finds your eyes, your quiet, your moment, and turns into understanding. In that small act, the distances shrink again. The universe folds inward until a galaxy can rest on a single breath, until the edge of everything feels as close as the pulse beneath your fingertips. Somewhere far beyond the reach of our eyes, in the deep heart of the Milky Way, something vast and unseen tugs on us. Every planet, every moon, every drifting speck of dust, each one of them moves in quiet obedience to that pull. It's the reason we travel through space at such astonishing speed, though it feels like perfect stillness beneath your feet. You are spinning, circling, and drifting all at once, caught in a slow, elegant dance around a center that lies 26,000 light years away. That means the light leaving that heart tonight won't reach us until 26,000 years have passed. Enough time for mountains to crumble and civilizations to rise and fade. Our sun and all its family, the Earth, the Moon, the bright shimmer of Jupiter's storms, the delicate ice of comets are bound together like stones at the end of a string. But that string stretches across the galaxy's invisible web, and our orbit around it is not quick like a year or a season. One revolution takes roughly 250 million years. 250 million years to make a single circle through the starlit plains of the Milky Way. When our solar system last passed through this same point, the world was unrecognizable. The great supercontinent, Pangaea, was still assembling. Coral reefs shimmered beneath shallow seas, and life had not yet learned to walk on land with confidence. The dinosaurs had not even begun their reign. In the time since Earth first formed, we've made fewer than 20 of these great circuits. 18 by our best count. 18 galactic years old. The number sounds small, almost tender, for something as ancient as our world. All of recorded human history, every invention, every empire, every whispered story beside a campfire fits within less than 1% of a single orbit. Rome rose and crumbled. Languages blossomed and vanished. The pyramids were built and weathered under desert wind, and all the while we drifted through a tiny sliver of our galaxy's path. The movement is so vast and unhurried that it folds the human story into something like a breath, a brief sigh between stars. And what waits at the center of this breathtaking spiral? What hidden presence holds such gravity that it keeps hundreds of billions of suns spinning in place? That question took humanity millennia to even begin asking. For most of our history, we believed ourselves the still point around which everything turned. The sun rose, the moon waxed and waned, the stars wheeled overhead like clockwork, and the earth beneath us did not stir. It was a beautiful illusion, so complete that even the wisest minds of the ancient world accepted it as truth. We seemed to stand at the center of creation. The heavens circled us like a grand chandelier. Then the telescope came, and with it, the quiet revolution of better measurements. Bit by bit, the illusion cracked. First, we learned that Earth orbits the sun, not the other way around. The revelation humbled us, but we could still imagine that perhaps our sun itself was at the center of something grander. A cosmic hearth where everything gathered in radiant order. But that hope, too, would soon dissolve. In 1917, an American astronomer named Harlow Shapley peered into the dark through glass and mathematics and found a different story. He studied globular clusters, ancient crowded spheres of stars that hover around our galaxy like glowing bees around a hive. Each cluster was a tiny galaxy unto itself, bright and old and bound by gravity's long patience. Shapley measured their distances, charted their positions, and expected to find them arranged neatly around the Sunday. Instead, He saw a pattern that pointed elsewhere toward the constellation Sagittarius, 30,000 light-years away. The clusters were gathering not around us, but around a distant center. Our solar system, it turned out, sits far from the heart of the Milky Way, off in a quiet neighborhood near the galactic edge. We were not the core. We were the outskirts, a small cabin in the wide suburbs of an enormous cosmic city. The discovery sent a shiver through astronomy. The sun was not the lamp of creation. It was one window in a sprawling metropolis of light. Shapley estimated the Milky Way's full width at about 100,000 light-years, an island of stars so wide that light takes 100 millennia to cross it. From our home in the suburbs, we sit about 26,000 light-years from the center, a comfortable distance from the chaos within. If the galaxy were a great disk of bread or a vast pizza spinning through space, we would live out near the crust, far from the dense, fiery center where the cosmic ingredients mix most violently. That might sound like bad real estate, far from the action, far from the glow, but it's a blessing in disguise. The core of the galaxy is a tumult of radiation, gravity, and motion so intense that no fragile world could survive there. It is bright beyond imagining, full of high-energy storms and the restless hunger of something massive and unseen. Out here, in our cosmic suburb, the light is gentler. Stars are spaced far enough apart for quiet to exist. It's a place where chemistry has time to grow patient, where life can gather itself into shapes that think and dream. The very calm that lets us look up at night and wonder comes from the safety of this distance. Still, Shapley's work raised a question that burned at the edge of every discovery that followed. If all these stars, all these clusters, all this dust and gas move together in a single majestic rotation, what sits at the center to hold them there? What mass could pull so fiercely on 100 billion suns and yet remain invisible to every telescope of the age? For decades, that mystery lingered. Astronomers could trace the motion of stars, but not the source of the pull. They knew the galaxy spun, but the heart was hidden, masked by veils of dust and distance. It wasn't until the late 20th century that new instruments, listening not to visible light, but to radio and infrared whispers, began to hear the beating of something extraordinary deep in Sagittarius. At the core of our galaxy sits an object with a mass 4 million times greater than our sun, packed into a space no larger than our solar system. A black hole, Sagittarius A*. Its gravity curves space-time so dramatically that nothing, not even light, can escape once it crosses the boundary called the event horizon. This is the silent conductor of our galactic waltz, the unseen anchor around which everything turns. It doesn't blaze with fire, it sings in gravity. The thought is staggering. The Milky Way, with all its arms and stars and drifting nebulae, is balanced around a heart of darkness, a place where matter folds into itself and the rules of the universe bend. And yet, from that mystery comes stability. It is the dark core that gives order to the luminous spiral. We owe our long, gentle orbit, and perhaps our very existence, to a shadow we can never see. When Shapley first mapped the galaxy, he could not have imagined such a thing. To him, the center was simply a coordinate, a point in the sky. But now we know that within that point lies a well so deep that even time behaves differently. Around it, stars swing like sparks from a forge, tracing loops measured not in years, but in centuries. Clouds of gas drift too close and vanish in silent flashes of X-ray light, feeding the invisible presence. It is terrible, yes, but also beautiful. A reminder that creation and destruction share the same hands. Astronomers still face the same paradox Shapley did. How do you measure the thing you live inside? It's like trying to chart a forest from beneath its canopy, or to draw the shape of an ocean while you float within its waves. We cannot step outside our galaxy to see it whole. So we learn by reflection, by listening to the way light echoes between its stars, by watching the slow drift of suns, by piecing together glimpses into a map no single eye will ever see complete. And maybe that's fitting. Maybe part of the wonder is that we're meant to feel our home through fragments, the glow of the Milky Way stretched across a summer night, the slow arc of planets against a field of black, the hum of a story that reaches from the heart of darkness to the quiet corners where we live. We circle that unseen center without hurry, passengers on a journey longer than memory, guided by a gravity we can't feel but somehow trust. Somewhere, far away, the galaxy turns. Stars move like sparks on invisible strings, and we, tiny and luminous, turn with it unaware most of the time, yet carried safely through the dark by the same deep rhythm that has spun since before life began. It began, as so many great discoveries do, with someone staring into the dark and wondering how to measure what cannot be seen. Harlow Shapley was one of those quiet dreamers who tried to take the measure of the universe with only light, mathematics, and patience. He could not step outside our galaxy to look back and trace its outline. No one could. So he turned to what the night offered him, faint clusters of ancient stars, globular clusters, glimmering like fireflies scattered far beyond the Milky Way's shining plain. He noticed they hung around the galaxy in every direction, a loose halo of brilliance. If he could chart where each one lived, he might draw the invisible edges of our galactic home. They would serve as survey markers in the void, distant lamps marking the borders of something too immense to grasp. But to turn their pattern into a map, he first had to solve a harder problem: how far away they truly were. Measuring cosmic distance is a riddle that tricks even the cleverest minds. Space gives no convenient landmarks, no mile markers, no echoing walls to bounce signals off. Yet Shapley had an idea. Certain stars, called Cepheid variables, pulse in brightness like cosmic heartbeats. They grow brighter and dimmer in a steady rhythm, and that rhythm tells a secret. The slower they pulse, the more luminous they are in truth. The faster they pulse, the dimmer. It is as if the universe built its own clock and ruler in one, the tempo of light revealing distance itself. Shapley studied those pulsations the way a musician might follow a metronome. He measured the time between each flare, determined the star's true brightness, and compared it to the faintness that reached his telescope on Earth. The difference between the two, between what should be and what appeared, told him how far the light had traveled, how much space had stretched between source and eye. It was an astonishing leap, a new language for measuring the immeasurable. With this cosmic ruler in hand, he began to chart the positions of globular clusters across the sky. Each one he pinned to his growing map, each distance carefully written down. When he stepped back from his numbers, a pattern emerged, a shape almost too grand to believe. The clusters formed a vast sphere, 100,000 light-years wide, and nestled within that sphere, the sun and its planets were nowhere near the middle. We were 2/3 of the way toward the edge, in a quiet suburb of stars. The revelation rippled through astronomy like thunder across mountains. 100,000 light-years. The mind staggers at such a span. Light, the fastest thing we know, takes 100 millennia to travel from one side of our galaxy to the other. To a human being, that is forever. Shapley's discovery transformed our sense of scale overnight. What we had once imagined as a cozy neighborhood turned out to be an empire of light, and our home, a small corner within it. What's more astonishing is how well his measurement holds even now. Modern telescopes and satellites have refined the numbers, but not the truth. Shapley, with his early instruments and his patient eyes, had already felt the right shape of the Milky Way. He gave humanity its first sense of the vast bowl of stars we inhabit, a spiral too large to ever see whole, too delicate to ever leave. But Shapley's clusters mapped only what could be seen, only the visible skin of the galaxy. Beyond that luminous boundary, another presence waited, something silent and invisible, yet heavier than everything else combined. For decades, astronomers puzzled over a strange behavior in the stars near the galaxy's rim. They moved too quickly, spinning around the center as if tethered by an unseen hand. By all known laws, they should have flown off into space like sparks from a wheel. The gravity of all the visible stars and gas simply wasn't enough to hold them. Something unseen was keeping the galaxy together. We began to call it dark matter not because it is dark, but because it hides from light entirely. It neither glows nor reflects, neither absorbs nor emits. Light passes through it as if it weren't there, and yet its gravity shapes everything we can see. Stars trace its outlines, galaxies dance to its pull. It forms an invisible scaffold on which the visible universe hangs. The numbers are startling. For every pound of ordinary matter, stars, planets, gas, dust, there are roughly 20 pounds of dark matter. Only about 5% of our galaxy is made of the familiar elements that build you and me. The rest is something utterly alien. This unseen halo of mass extends far beyond the Milky Way's shining disk, enveloping it in a sphere nearly 2 million light-years across. The visible galaxy, that graceful spiral you see on posters and telescope photographs, is merely the bright center of a structure 20 times larger than its glow. Think of it this way: if our galaxy's stars form a flashlight beam in a dark room, then the dark matter is the entire room itself, the unseen air, the walls, the vastness that surrounds the light. We live within the beam, surrounded by something enormous and transparent. Billions upon billions of dark matter particles drift through your body every second, silent and indifferent, leaving no trace. You are more porous to the universe than you realize. No telescope can see this hidden ocean, but its gravity is unmistakable. It bends the paths of stars and warps the orbits of galaxies, like wind bending tall grass. Astronomers watch how light curves as it passes through space, pulled sideways by invisible mass, and from that curvature, they can map the unseen. The shapes we call galaxies are really the glowing tips of far larger structures made of dark matter. Without it, the Milky Way would not hold together. Its arms would unravel into the void. It's humbling to realize that nearly everything we know, the sun, the earth, the atoms in our hands, make up only the smallest sliver of reality. 95% of the cosmos consists of something we cannot touch or even properly imagine. Yet we live within its embrace every moment, moving through its currents like fish unaware of the sea. The existence of this invisible halo reshapes not only our science, but our sense of being. It tells us that the universe hides more than it reveals, that the bright, familiar stars are only whispers above a deeper silence. It suggests that creation is built on mystery, that what we can see is only the foam on a vast, unseen tide. And this halo has its own boundaries. Far beyond the faintest edge of starlight, the gravity of our galaxy weakens, and the pull of intergalactic space begins. Beyond that line, another mystery begins to gather, something stranger, Even then, dark matter, something that does not merely hold things together, but pushes them apart. But for now, stay with this thought. You are part of a system that circles an invisible core, itself wrapped in a halo of unseen matter, all of it gliding through the universe like a dream through sleep. What we call darkness is not absence, it is structure, quiet and essential. Somewhere within that stillness, a grain of dust on a small planet is thinking about the shape of the whole, and that thought, that flicker of awareness, is enough to make the darkness glow. In the late summer of 1977, two small machines left Earth and began drifting into the dark. They were no larger than a family car, yet they carried with them the sound of human breath, the songs of whales, greetings in many languages, the pulse of our planet's heart. Voyager 1 and Voyager 2 were their names. Twin messengers hurled toward the edges of the solar system. They slipped past Jupiter and Saturn, past Uranus and Neptune, their cameras catching worlds that had never been seen up close, worlds once thought of only as points of light. Now, decades later, they keep going. Each races outward at about 38,000 miles per hour, fast enough to cross the United States in less than 5 minutes. They are the fastest objects humanity has ever sent into the dark. But even that speed is a whisper against the scale of the galaxy. At that pace, Voyager 1 would need roughly 173,000 years to reach the next star, longer than 10 times the span of recorded human civilization. Think about that. From the first fires struck by stone, to the rise and fall of empires, to the invention of flight and music and science, all of it fits comfortably into a time shorter than a single trip to our nearest neighbor. And yet that neighbor, Proxima Centauri, sits only a few steps away in galactic terms. To cross the entire Milky Way, Voyager would have to travel for 1.7 billion years. By the time it finished, new continents would have formed, oceans would have changed shape, and the traces of humanity would have eroded to dust. When that journey began, if we imagine it in slow motion, life on Earth would have been nothing more than green films of algae and drifting bacteria. No trees, no animals, no songs of birds or rustle of leaves, just cells dividing endlessly, patiently, beneath a sun that shone a little fainter than it does today. In the billion-plus years it would take to cross the Milky Way, life evolved from those single cells into coral reefs, forests, whales, and the minds that built the Voyagers themselves. It's as if evolution completed an entire epic while our ship was still on its first leg of the trip. And even this thought assumes perfection, that Voyager could fly forever without fuel, without decay, without being torn apart by micrometeorites or cosmic dust. In truth, the spacecraft are slowly falling silent. Their power comes from the slow decay of plutonium, and by the end of this decade, both will drift into complete radio quiet. They will continue to coast through interstellar space, their golden records intact, carrying messages that no one may ever hear. They will be, perhaps, the last monuments to our species when the continents have shifted and the sun itself has changed. Out there, between the stars, Voyager sails through an emptiness so complete it seems less like a place and more like the idea of nothing. Each cubic centimeter of interstellar space contains fewer than one atom. Even our best vacuum chambers on Earth cannot match that purity. The spacecraft may not encounter a single grain of dust for millions of years. The galaxy is made of such spaces, vast stretches of quiet between islands of light. And yet, the emptiness deceives. Our galaxy is anything but empty. It holds roughly 400 billion stars, more suns than there are grains of sand on every beach on Earth. Try to count them, one star every second, day and night, without rest. It would take over 12,000 years just to finish the list. If everyone alive today joined the effort, each person would still be responsible for 50 stars. A strange thought that you could have your own handful of suns to care for. These stars are not all the same. Some blaze blue-white, fierce and short-lived, spending their fuel in a few million years before collapsing into ghosts of themselves. Others smolder red, content to burn slowly for hundreds of billions of years longer than the universe has yet existed. Some weigh barely enough to ignite fusion, faint embers compared to our Sunday. Others are titans, packing dozens of solar masses into cores hot enough to forge elements heavier than iron. Many stars are born not alone but in pairs, circling one another in endless motion. Some gather in dense clusters, stellar cities where hundreds or thousands of suns crowd together, their combined light washing space in silver. Others beat with steady rhythms, expanding and contracting like lungs. Astronomers call them pulsars or variables, but their flickering is a kind of heartbeat that can be timed across galaxies. Around these stars, planets spin billions upon billions of them. We now believe at least 100 billion worlds orbit in the habitable zones of their suns, where liquid water could shimmer on their surfaces. 100 billion possible homes for life, scattered like seeds through the spiral arms of the Milky Way. Some may be barren and silent. Others might carry oceans and weather, forests and skies. And somewhere, perhaps, a civilization might stand beneath alien constellations, wondering whether they too are alone in the dark. Wondering whether another small world once sent out golden records into space. The oldest stars of our galaxy have been burning for over 13 billion years, nearly as long as the universe itself has existed. When they were born, there were no planets yet, only hydrogen and helium, the heavy elements that make up rocks, oceans, and bodies. Carbon, oxygen, iron had not yet been forged. Those stars have watched the universe change from a thin mist to a structure of galaxies and clusters and endless motion. Some of their planets, if any formed, could have nurtured life billions of years before Earth cooled enough for rain. Imagine civilizations so ancient, their stories might have ended before our sun began to shine. All of these stars, every shade and rhythm, do not scatter randomly through space. They arrange themselves in a pattern, a thin, luminous disk about 1,000 light-years thick and 100,000 light-years wide. That is our galaxy's shape, a spiral of arms winding gracefully around its hidden center. Our solar system lies about 26,000 light-years from that core, right in the middle of one of those arms, orbiting calmly amid the dust and glow. When you stand outside on a clear night and see the Milky Way arching overhead, what you are seeing is the disk from within. You are looking sideways through the thickest part of the spiral, peering through billions of stars all layered together, their light mingling into a soft, milky river across the dark. Each pinpoint is a sun, each sun with its own system, its own story. Together, they form the faint band that our ancestors mistook for smoke or spilled milk across the heavens. To the naked eye, it looks delicate, a whisper of light on black velvet. But what you see is the concentrated glow of half the stars in the galaxy, shining across unimaginable distance. The nearest may be a few light years away, the farthest tens of thousands. The light from those distant suns began its journey before humans learned to make tools, before fire found a hearth. By the time it reaches you, it has crossed the ages to fall gently on your eyes, a small act of cosmic grace. And yet, this breathtaking congregation of 400 billion stars is only the visible surface of something even grander. Beneath the starlight lies a skeleton of dark matter holding everything together. And beyond that, the galaxy continues its halo, its invisible currents, its restless edge. But for now, it is enough to linger in this moment, to remember that every flicker above you is a star older than all our stories, and that the space between those flickers is not empty at all, but waiting. The voyagers, now far beyond the pull of the sun, drift through that waiting space, carrying whispers of who we are. Perhaps one day, long after their signals fade, another intelligence will find them and listen, and in that quiet exchange, across the silence of light years, the Milky Way will once again feel a little smaller, a little more like home. The Milky Way does not sit still. It turns slowly, gracefully, like a great pinwheel made of dust and stars spinning through the dark sea of the universe. But its motion is nothing like the spinning of a record on a turntable, nothing like a planet rotating beneath your feet. A record moves as one. Every point completes a circle in the same amount of time. The galaxy moves differently. The stars closer to the center race ahead, while those farther out lag behind, each orbiting at its own tempo. It is as if the Milky Way were a vast, luminous waltz, its dancers scattered across the floor, each keeping rhythm with a different beat. Our sun is one of those dancers, circling the galactic heart from a distance of about 26,000 light-years. One full orbit, one cosmic year, takes 250 million Earth-years to complete. That means, since our planet was born, it has made the trip only 18 times, 18 galactic years. In all the ages of mountains rising and falling, of oceans forming and continents drifting, of life creeping from sea to land and learning to fly and speak and dream, Earth has circled the galaxy fewer than 20 times. Pause on that number for a moment. The last time our solar system was in this same spot, along its orbit, the continents were merging into the ancient supercontinent, Pangaea. There were no dinosaurs yet, no birds, no flowers, no grass. The world was a green swamp of ferns and primitive reptiles, the air thick with oxygen, the sky bright with unfamiliar constellations. The entire age of dinosaurs, from their first steps to their sudden extinction 65 million years ago, lasted only about 1/4 of a galactic year. And everything we call human history, the rise of cities, the carving of words into stone, the first sails catching wind, the leap into space has taken place in less than 100,000th of a single galactic orbit. If the galaxy's rotation were compressed into a single Earth year, all of human civilization would exist in the final seconds before midnight on December 31st, a brief flicker of thought before the clock strikes 12. Because our galaxy rotates so slowly, its neighborhoods change. The stars that appear side by side in the night sky will not remain companions forever. Over millions of years, their paths drift apart. The constellations that seem permanent to us, Orion, Cassiopeia, the Big Dipper, are only temporary alignments, patterns of light frozen by the limits of human time. Given enough centuries, they will melt and reform into new shapes that no eye today would recognize. Our sun's journey around the galaxy isn't flat either. As we orbit the center, we also move up and down through the galactic disk, bobbing gently like a boat riding invisible waves. Every 33 million years, we rise above the midplane, and every 33 million, we sink below it. completing one full oscillation roughly every 66 million years. Some scientists suspect that these rhythmic crossings might influence the story of life on Earth. When our solar system passes through the dense middle of the disk, it may brush against regions rich in dust and debris, cosmic clouds that could disturb the distant Oort cloud and send a rain of comets inward, some of which might collide with planets, perhaps even Earth. In this way, our planet's own cycles of life and extinction might echo the slow pulse of our orbit through the galaxy's luminous heart. All across the Milky Way, the stars follow this pattern of unequal speeds, a cosmic phenomenon called differential rotation. The ones near the center spin quickly, looping around the galactic core in mere tens of millions of years. Those on the outskirts take much longer, like the outer horses on a carousel that can't quite keep pace. The motion creates a spiraling rhythm, arms of gas and stars that twist and curl, each pattern shifting as the galaxy breathes. At the very center of this grand rotation lies something darker and stranger than any sun. Sagittarius A*, the supermassive black hole around which everything turns. It is small by galactic standards, smaller than our solar system, but it holds within it the mass of 4 million suns. The black hole is the silent anchor of the Milky Way, the heavy core whose gravity binds 400 billion stars into a single, coherent dance. To imagine it, think of a presence so dense that space itself cannot bear its weight. The closer you approach, the more time bends. Near its boundary, the event horizon space stretches and folds like cloth drawn into a whirlpool, and time itself slows to a crawl. A clock placed near that edge would tick more slowly than yours does here on Earth. 1 minute there could mean hours, days, or centuries for us. It is a place where the familiar rules of reality dissolve, and the universe reveals its deeper strangeness. We cannot see Sagittarius A times directly. It swallows light along with everything else that strays too close. Yet we know it is there, because the stars around it move in ways nothing else can explain. Some whip through their orbits at speeds exceeding 3,000 miles per second, tracing tight, brilliant loops through the invisible gravity well. Astronomers have watched these stars for decades, measuring their dizzying motion, using them like lanterns to outline the shape of the darkness itself. Sometimes, the black hole feeds. A drifting cloud of gas, or an unlucky star, wanders too near, and gravity grabs hold. The doomed material spirals inward, compressing, heating, spinning faster and faster as it approaches the edge of no return. In those final moments, it glows in X-rays and radio waves, one last cry of light before vanishing forever. From 26,000 light-years away, we can detect that cry, a flare so distant that it began before human beings existed. Recent observations show that Sagittarius A times is not a quiet eater. It spins fast, almost unimaginably fast, dragging space itself along with its rotation in a phenomenon known as frame dragging. Einstein's general relativity predicted this effect long before we could observe it. It means that near the black hole, space-time doesn't just curve, it swirls like honey stirred with a spoon, carrying everything in its grip. Astronomers believe this dark engine formed early in the Milky Way's history, billions of years ago. It may have started as a smaller black hole, born from a collapsed star, then grew over ages by swallowing gas, dust, and other stars. As it fed, its gravity became the organizing force of the galaxy, pulling surrounding material into the graceful spiral we see today. The Milky Way's beauty, its structure, even its stability, all arise from the quiet tyranny of this hidden core. The region around the galactic center is a storm of extremes. Radiation flares from collapsing stars. Magnetic fields twist and snap. Massive suns are born and die in rapid succession, living fast and burning bright, before exploding into supernovas that seed the surrounding space with heavy elements. It is a place of both destruction and creation, where chaos gives rise to order and new stars emerge from the ashes of the old. We are far from this chaos, 26,000 light-years away, wrapped safely in one of the galaxy's spiral arms, but we still feel the black hole's distant tug. It is the invisible metronome that keeps our solar system's rhythm, the unseen hand that ensures our orbit continues. Without it, the Milky Way would unravel, its stars flying off into the void. Even so, the black hole is just one thread in the vast fabric of the galaxy. Around it, dust and gas swirl in luminous arms. Between those arms, stars glide through space, each on its own path through the dark. Everything moves, everything turns. And somewhere out in the suburbs of this rotating city of light, our sun drifts quietly through its long orbit, carrying with it a blue planet that spins and dreams, marking time not in days or years, but in cosmic heartbeats. If you step outside on a clear night, that motion is invisible. The stars seem still, yet beneath that stillness, the whole galaxy is flowing, slow as breath, steady as tide carrying you, the Earth, and all we know through a turning that will not finish for another 250 million years. And when it does, when we complete another circle through the Milky Way's arms, there will be new continents, new species, and perhaps new minds looking up into the same night, feeling the same quiet wonder at the dance we have always been part of. We live in the middle of a mystery we can never quite step outside to see. Every other galaxy in the sky, those silver whirlpools you glimpse through telescopes or in photographs, can be observed from the outside. We can see their elegant spirals, their bright cores, their sweeping arms fading into the dark. But our own galaxy is different. We are inside it, like dreamers trapped within the story they are trying to read. The Milky Way stretches around us in every direction, vast and luminous, but we can never rise above it to see its true shape. It's a strange predicament trying to study the house while you live inside it. Imagine being locked in a basement apartment with no windows, asked to draw a map of the entire city above. You could send messengers to different street corners, collect their descriptions, piece together clues, but you would never have the satisfaction of stepping back and seeing how all the roads connect. That is our situation exactly. We are tenants in a galactic mansion whose walls are made of stars, and though we can wander its rooms, we will never stand outside to see its full design. When we look toward the center of the Milky Way, we gaze through the thick, dusty plain of the galactic disk. It's a crowded neighborhood, billions of stars, rivers of gas, clouds of carbon and iron drifting between them. This cosmic haze absorbs light like fog swallowing the beams of a headlight, blocking our view after only a few thousand light-years. Beyond that distance, visible light simply vanishes into the dark, leaving us blind. But the universe gives us other senses. Radio waves and infrared light can slip through the fog where ordinary starlight fails. They pierce the darkness like music drifting through a wall. With these longer wavelengths, astronomers can probe deeper into the hidden core of our galaxy, mapping regions that the eye cannot see. Still, even these methods are limited. We live within the galactic disk itself, looking sideways through its dense plane. It's like staring through a forest from the ground. you see only trunks and branches tangled together, no hint of the forest's true shape. That's why the Milky Way appears as a hazy ribbon across our sky, a blending of countless distant suns, their light merging into one continuous glow. At such distances, the stars blur into one another, losing their individuality. We can no longer tell which ones are close, which far. The three-dimensional depth of our galaxy flattens into a single shimmering band. And yet, being inside the Milky Way offers gifts that outsiders can never have. Because we live here, we can study our stellar neighbors up close, measuring their chemistry, watching their flares, detecting the gentle dimming of starlight when planets pass in front of them. We can map the clouds of gas and dust that cradle newborn stars. We can watch the sky move not as a frozen photograph, but as a living system, full of shifting patterns and subtle rhythms. In recent years, our maps have become astonishingly precise. The Gaia spacecraft, launched by the European Space Agency, has measured the positions and motions of over 1 billion stars. Each star is like a glowing pin on a vast three-dimensional model of the galaxy, a model that breathes, because every pin is moving. Gaia's data allows astronomers to trace the slow drifts of entire star populations, to see ripples in the galactic disk, to read the Milky Way's history written in the language of motion. For the first time, we can begin to imagine how the stars flow and swirl together, but we will never have what we most long for. The outsider's view. We cannot step beyond the galaxy and look back. We remain forever inside our own creation, like a family living in a mansion so large that no one has ever seen the whole facade. We explore corridors, measure rooms, listen for echoes that hint at what lies beyond the next wall. The Milky Way is both our home and our horizon, and within this unseen structure lie features more subtle still patterns of matter and motion that we cannot see directly, only infer through the faint tug of gravity. The spiral arms that give the Milky Way its famous shape are not solid structures at all, not great tendrils of fixed stars. They are illusions of movement, like waves traveling across an ocean whose water stays behind. Most people picture the galaxy as a giant pinwheel turning in space, its arms fixed in place as it spins. But that's not how it works. The spiral arms are more like traffic jams on a busy highway. From a distance, the jam looks solid, a snake of taillights crawling along the road. But the cars, the stars, do not remain there. They move through the jam, slowing as they enter, speeding up as they leave, while the jam itself keeps its shape, traveling slowly down the highway. So it is with our galaxy. The spiral arms are compression waves, zones where gas and dust and stars momentarily crowd together. As these waves sweep around the galaxy, they squeeze giant clouds of gas until the pressure becomes too great. Within those clouds, gravity takes over, pulling the material inward until new stars ignite young, brilliant, blue-white suns that burn fiercely and briefly. Their light outlines the spiral arms, tracing the wave's path through the darkness. These young stars live fast and die young. Some explode as supernovas before they can drift far from their birthplaces, scattering elements like iron and gold back into space. Their light fades, and the wave moves on, leaving behind empty space until the next compression passes. What we see as solid arms are really zones of perpetual birth and decay, luminous gatherings that move across the galaxy like ripples across a pond. Our solar system doesn't sit inside one of these arms. We drift between two of them, in a quieter region called the Orion Spur. a kind of side street between the Milky Way's grand avenues. About 50 million years ago, the Sun last passed through one of the major spiral arms, and it will be another 10 million years before it meets the next. Each passage brings us through regions dense with radiation, gas, and cosmic dust conditions that may subtly affect the climate and life on Earth. Some researchers even wonder whether these crossings leave faint imprints in the fossil record, written in cycles of extinction and renewal. The spiral structure itself turns far more slowly than the stars that move through it. The Milky Way's arms complete a rotation only once every few 100 million years, while the stars orbit several times faster. This difference in speed keeps the arms from winding up and disappearing. It's a delicate balance, maintained by the interplay of gravity, density, and motion. A long, slow symphony written in light. We still do not fully understand what sustains these spirals. Some scientists think the gravitational pull of smaller satellite galaxies' companions like the Magellanic Clouds might stir up waves in our galactic disk, pumping energy into the system. Others point to the bar-shaped core at the Milky Way's center, a dense region of stars whose rotation might drive the pattern outward. Recent observations reveal that our spiral arms are far from perfect. They branch and split, weave together and unravel, forming bridges and gaps that shift over tens of millions of years. From our little corner, we see only fragments of this vast geometry, yet those fragments are enough. The Milky Way's spirals are not walls or boundaries. They are currents, constantly changing, constantly creating. They remind us that even in a universe built on gravity and precision, there is room for motion that feels almost alive. If you step outside tonight and find that soft band of light stretching across the sky, know that you are looking into one of those waves, into a compression of starlight that began long before humans could imagine such a thing. Each glow is a reminder that we live inside what we cannot leave, a spiral of dust, gas, and wonder, and that every turn of the galaxy carries us farther into the mystery of our own home. Beyond the spiraling arms and the gentle waves of starlight that define the Milky Way, something larger and quieter unfolds. Our galaxy, vast as it seems, does not wander alone through the cosmic dark. When the view widens, when you imagine stepping far enough back to see not just our luminous disk, but the faint whispers of light beyond it, you find company. Dozens of smaller galaxies drift around us, caught in our gravity like leaves circling a deep whirlpool. These companions are dim and delicate things. The two brightest, the large and small Magellanic Clouds, can be seen from the southern hemisphere, soft patches of glow against the night, as if the Milky Way had brushed against the sky and left pieces of itself behind. Sailors once used them as beacons, marking direction by their light, never knowing they were whole galaxies with millions, even billions, of their own suns. The large Magellanic Cloud lies about 160,000 light-years away. The small Magellanic Cloud about 200,000. Both are well beyond the Milky Way's visible edge, yet still bound within its invisible reach. That reach is not the tidy border of a map, but an immense gravitational field that stretches hundreds of thousands of light-years in every direction. Within it, the Magellanic Clouds are caught, their shapes pulled and stretched as they circle our galactic center. Streams of gas and stars unravel from them like threads of silk torn loose, trailing behind in long, luminous ribbons. These streams wrap around the galaxy, ghostly evidence of the slow, patient tug of gravity at work. The Magellanic Clouds are only the largest and brightest of our attendants. Around the Milky Way, more than 30 smaller satellite galaxies drift in quiet orbit, faint and fragile. Some bear poetic names borrowed from the constellations in which we see them: Draco, Sculptor, Fornax. Each one contains only a few million stars, so dim that they blend into the background of our sky. Some are so poor in ordinary matter that they exist almost entirely as shadows of dark matter, invisible except through their pull on the stars around them. They are the quiet siblings of our galactic family, their light barely strong enough to reach us. Over cosmic time, our gravity treats these companions with a kind of ruthless patience. As they orbit, tidal forces stretch and strip them, pulling their outer layers of stars away until only their dense cores remain. Those lost stars drift into the Milky Way's disk, becoming part of us. In this slow, celestial hunger, we are growing, consuming smaller galaxies one by one, folding them into our spiral, like tributaries, feeding a great river. Astronomers call it galactic cannibalism, but it feels less like violence and more like inevitability, the universe's quiet method of shaping larger from smaller, of turning fragments into wholes. This process tells us something profound about what we are. The Milky Way, we can see the ribbon of stars. The glowing spiral in photographs is only the visible heart of something vastly larger. Around it stretches an invisible halo of dark matter, 2 million light-years across, 2 million light-years, 20 times wider than the disk of stars. The dark matter halo is the true boundary of our galaxy. Though we can neither see nor touch it, it reveals itself only through gravity, an unseen architecture that defines the way everything inside moves. Imagine our galaxy as a cherry pit resting at the center of a basketball. The pit is the bright disk of stars, 100,000 light-years wide, full of light and dust and life. The basketball is the dark matter halo, enormous and intangible, filled with invisible particles that interact with nothing but gravity. Within that vast sphere lies almost all of our galaxy's mass, hundreds of billions, perhaps trillions, of solar masses worth of material we cannot see. We live deep inside it, like fish swimming in the thinly lit shallows of an ocean whose depths extend far beyond imagination. The halo shapes everything within its reach. The small satellite galaxies orbit through it as though swimming through an invisible sea, feeling its currents without ever seeing its surface. Their orbits twist and wobble, tracing out the hidden mass that surrounds us. Recent computer models suggest that this halo is not smooth, but teeming with smaller clumps, thousands of subhalos, dense knots of dark matter drifting through the larger cloud like schools of unseen fish. Some of these subhalos may be heavy enough to gather gas and dust, birthing small, dim galaxies of their own. Others remain forever dark, never touching light, never leaving a visible mark. The halo's gravity also reaches far beyond the stars, tugging at the thin gas that floats between galaxies, drawing it inward. This slow, steady inflow provides the fuel for new stars, feeding the Milky Way's long, patient cycle of birth and death. At the same time, the halo acts as a shield, its immense mass deflecting the high-speed particles and wandering fragments that drift through intergalactic space. In a sense, it shelters us, absorbing the blows of a restless cosmos, so that the delicate structures inside can endure. Even so, its boundary is uncertain, not a wall, but a fading whisper. The density of dark matter thins gradually until it merges seamlessly with the vast cosmic web that fills all of space. There is no clear edge, no final border where the Milky Way ends and the intergalactic void begins. only a gentle blending, the way a shoreline melts into the sea at high tide. To think of it this way is humbling. The galaxy we call home, with all its stars and stories, floats inside a sphere of invisible substance that defines our place in the universe. It binds our companions to us, shapes the paths of their orbits, and connects us to the wider cosmic web beyond. We are creatures of light, moving within a skeleton of darkness. Each star, each planet, each breath, taking shape inside a framework we can barely sense. When you look up and see the Milky Way across the sky, remember that what you see is only the thin, glowing skin of a much deeper body. Beyond that light stretches a cathedral of shadow, silent, ancient, and immense, holding us in its arms as we drift together through the dark. The farther we look into the Milky Way, the more it reveals itself as something alive, restless, flexible, always in motion. For all its beauty, our galaxy is not a perfectly balanced disk spinning neatly through space. It bends and trembles, tilts and sways, as if caught in a slow dance with unseen partners. Even the starlit plane we imagine as flat ripples like the surface of disturbed water. The outer edges of the galactic disk rise and fall in long, slow arcs, sending waves inward toward the center. From our vantage point inside it, we hardly notice, yet the whole structure of our home is flexing around us. Recent observations have shown that this warp in the Milky Way is not fixed in place, it slowly turns. By studying variable stars of different ages, astronomers have discovered that the entire warp precesses, or rotates backward, about 1/1200th of a degree every million years. It's almost nothing in human terms, yet, on cosmic timescales, it's as if the galaxy itself is breathing. The curve of its great disk drifts gently in the opposite direction of the star's orbit, twisting the Milky Way into a subtle spiral of motion upon motion. What causes such an immense wobble? The answer lies in the invisible ocean of dark matter that surrounds us. The halo that holds the galaxy together is not a perfect sphere. It is slightly flattened, shaped more like an elongated football. As the stellar disk spins inside this uneven field, gravity tugs at it unevenly, creating torque, pulling the disk upward in one direction and downward in another. The result is a long, slow oscillation, a cosmic wobble that will continue for as long as the galaxy lives. It helps to imagine a coin spinning on a tabletop. At first, it moves smoothly, a blur of silver, but as it begins to slow, it wobbles, tilting from side to side in wider and wider arcs, before finally falling flat. Our galaxy behaves like that coin, except its tabletop is a vast, invisible halo, and its spin will last billions of years before coming to rest. The wobble is not chaos, it's rhythm, a steady beat written into the very shape of our home. Every part of the Milky Way feels that rhythm. The stars in the outer disk rise and fall through space like boats on a cosmic tide. Clouds of gas are stretched and compressed as the waves pass through, their densities changing, their motions adjusting. Even our own sun, 30,000 light-years from the center, joins in this subtle swaying. The entire solar system moves with it, lifted and lowered by the undulating fabric of the galaxy. This slow motion tells astronomers a great deal about the unseen matter shaping it. By measuring the way the disk precesses, they can infer the exact shape and orientation of the dark matter halo that encloses everything. It's one of the few clues we have about dark matter's true distribution, an invisible fingerprint pressed into the Milky Way's structure. The wobble, in this sense, is not just motion, it's communication. The galaxy itself is telling us something about the darkness that defines it. But the Milky Way doesn't wobble alone. Its smaller companions, the large and small Magellanic Clouds, and the other faint satellite galaxies add their own gravitational tugs. Their orbits twist around us, pulling on the disk in irregular beats, changing the pattern of its precession. These additional torques complicate the motion, adding ripples to ripples, layers of motion woven together like a complex galactic melody. The result is a living system in flux, never static, always adjusting to invisible pressures both within and beyond. And yet, all this quiet, slow motion is only the prelude to a much grander transformation. Because the Milky Way is not alone in the dark, it has a twin rushing toward it. Far across the intergalactic void, just 2.5 million light-years away, the Andromeda Galaxy drifts closer. Its speed almost inconceivable, roughly 250,000 miles per hour. To the naked eye, it appears as a faint smudge in the autumn sky, delicate and harmless. But that soft glow is the light of 1 trillion stars, an entire island universe on a collision course with our own. In about 4.5 billion years, long after the sun has begun to fade, Andromeda will arrive. It will not crash into us in an instant, but merge slowly, gracefully, over the span of eons. Long before the first contact, the gravitational attraction between the two galaxies will begin to tug at their shapes. The Milky Way's outer arms will stretch toward Andromeda's, their stars flung outward into tidal streams that bridge the gap between them. As they draw nearer, their delicate spirals will distort and twist into vast arcs of light. The collision itself will unfold like a dream in slow motion. Over billions of years, the two galaxies will pass through one another, separate, and fall together again, each encounter scattering more stars, stirring gas into new clouds, igniting waves of starbirth. To the stars themselves, this will not be a fiery apocalypse. They are too far apart for direct collisions. Instead, they will slip past one another like two swarms of fireflies, their paths reshuffled, but their lights unharmed. Our sun, small and steady, will likely survive, but its place in the new galaxy is uncertain. Simulations suggest that as gravity flings stars outward, our solar system may find itself pushed toward the outskirts of the merged structure, or even expelled into the open dark, drifting between galaxies. If that happens, Earth, long dead by then, will orbit a lonely star with no galactic home, wandering the emptiness between worlds. When the merger finally settles, the Milky Way and Andromeda will have fused into something new, a single, massive, elliptical galaxy, its spiral arms erased, its stars mixed together in a luminous cloud. Astronomers have already given this future structure a name, Milkomeda, the union of two giants. From far away, it will look serene, as if it had always been that way, but its calm light will be the memory of violence, the echo of tides that once tore across the heavens. Even in this distant future, the old wobble will remain, its ripples hidden within the larger whole. The new galaxy will inherit the scars of its parents, the distortions of the Milky Way's disk, the trails of the Magellanic Clouds, the faint gravitational fingerprint of dark matter itself. Nothing in the cosmos ever truly disappears. It only transforms. Tonight, when you look up and see Andromeda's faint shimmer, remember, that glow is not just another galaxy. It is a promise of what our home will become. Across the unimaginable gulf of time, two rivers of stars are flowing toward one another, destined to meet and merge. We are already part of that slow embrace, already moving in the current of a future written in light. Even as the Milky Way and Andromeda draw closer, their future collision is only part of a much larger choreography, a motion written across hundreds of millions of light years. When those two spirals finally touch and merge, their graceful arms will dissolve into a storm of stars. At the heart of that storm, their supermassive black holes, each millions of times heavier than our sun, will find each other. Over billions of years, these two invisible giants will spiral inward, drawn together by the same gravity that once held their galaxies apart. As they close the distance, they will release energy in a form almost unimaginable, gravitational waves, rippling through the fabric of space-time itself. When they finally merge, the blast of energy will outshine. In pure gravitational power, everything our sun will emit in light during its entire 10 billion year lifetime. The two great cores will become one, a single, immense black hole, more than 5 million solar masses strong, reigning at the center of the new galaxy. The structure that remains after this union will bear little resemblance to the elegant spirals we know. Gone will be the arms, the delicate disk, the symmetry. The merged system, already given a name, Milky will become an enormous elliptical galaxy, a soft, rounded cloud of stars with no defined form, a monument to the collision of giants. It will be quieter in some ways, its bright arms gone, but deeper in others, its stars scattered into a broad, glowing halo. And yet, even this colossal event is only a ripple on a far grander scale. The Milky Way and Andromeda, for all their mass and magnificence, are not drifting alone. They belong to a greater family called the Local Group, a cluster of a few dozen galaxies that move together through space. And that whole group, galaxies and dark matter and all, is being pulled towards something vast and unseen. We are not stationary wanderers. We are passengers on a current of gravity, sliding toward a destination we can't yet see. Astronomers call this gravitational sink the Great Attractor, a name that captures both its mystery and its pull. It lies roughly 150 million light-years away, in the direction of the constellations Hydra and Centaurus. From Earth, it's hidden behind the dense stars and dust of our own galactic disk, in a region aptly named the Zone of Avoidance. Because our view is blocked, we can only infer its presence from how galaxies move. Thousands of them, whole clusters, are streaming toward that same invisible point at 600 miles per second. Whatever the Great Attractor is, its influence reaches across hundreds of millions of light-years, tugging on entire superclusters of galaxies, as if drawing them into a cosmic whirlpool. The combined mass of tens of thousands of galaxies seems to be concentrated there, in a region perhaps 500 million light-years wide. It is one of the largest known structures in the universe, a gravitational anchor, shaping the flow of matter on scales too immense for our minds to truly hold. We can see fragments of it: the Hydra cluster, the Centaurus cluster, the Norma cluster, massive gatherings of galaxies revealed through telescopes that pierce the obscuring dust. Yet even when astronomers add up all the visible mass, the numbers fall short. The pull is too strong. Something unseen, dark matter perhaps, or additional hidden galaxy clusters must contribute to its gravity. The full structure remains veiled, a shadowed continent beyond the glare of our own stars. What this means is that our galaxy does not drift through space at random. The Milky Way is following a course set by these immense gravitational tides. Like a leaf caught in a river current, We are moving along paths carved by cosmic forces much larger than ourselves. The stars around us, the galaxy itself, the local group, all are being carried along by an invisible flow toward the great attractor, and beyond even that, towards something larger still. Farther out lies the Shapley supercluster, a titanic congregation of thousands of galaxies that may be the true destination of this cosmic journey. The Milky Way, Andromeda, and their companions are being drawn toward it slowly, steadily, over billions of years. We are part of that migration, drifting across the universe towards structures whose full extent we may never know. But the story of motion and merger doesn't just happen on intergalactic scales. It happens right here within our own galaxy, where the Milky Way itself acts as a predator in an endless feast. Floating nearby, a small, fading companion known as the Sagittarius dwarf galaxy is being torn apart by our gravity. Once home to billions of stars, it now trails ribbons of them across our sky, long glowing arcs that wrap around the Milky Way like strands of silk. Every time this little galaxy plunges through our disk, tidal forces stretch and shred it further, stripping stars from its edges and scattering them into our halo. Over billions of years, what was once a separate galaxy has become part of ours. Computer simulations suggest that the Sagittarius dwarf is nearing its end. With each pass, it grows fainter, smaller, more dispersed. Within a few billion years, it will dissolve entirely, its stars joining the Milky Way's own stellar population as if they had always belonged. It is a quiet kind of destruction, slow but unstoppable, a process that has likely shaped the Milky Way since its birth. The smooth halo of stars that surrounds our galaxy is not truly smooth at all. It is made of ghosts, remnants of hundreds of smaller galaxies consumed over 10 billion years. Their stars drift together now, indistinguishable from our own, yet they carry the memory of where they came from. If you could trace the chemistry of those stars, you could still hear the echo of their origins, the faint imprint of ancient worlds long gone. The large Magellanic Cloud, our brightest nearby companion, may be next. For a long time, astronomers thought it was locked in a stable orbit around us, circling like a faithful moon. But recent measurements suggest something more dramatic. It may only recently have been captured by our gravity. Over the next several billion years, it will spiral closer, and as it does, the Milky Way's tides will begin to strip away its stars and gas. That material will fall into our galaxy, triggering bursts of star formation, lighting up new regions of the spiral arms. Its death will feed our rebirth. Even smaller satellite galaxies, tiny dim systems with just a few thousand stars, show scars from the same slow violence. Many are stretched into elongated shapes, their stars unevenly scattered by our gravitational pull. Some are reduced almost to threads, thin streams of light barely holding together. These are the fossils of galactic growth, the evidence of the Milky Way's long appetite. And this is how galaxies live. They do not grow by quiet accumulation, but by consuming one another, by merging, absorbing, devouring. Every great galaxy in the universe is a patchwork of those that came before it, stitched together by gravity's relentless hand. The Milky Way is no different. Its calm appearance hides a history of collision and hunger, a story written not in blood but in starlight. So when you look up at the soft band of the Milky Way on a clear night, remember, you are looking at the product of countless cosmic meals, at a galaxy still reshaping itself with every passing age. We orbit within something ancient yet unfinished, a creature of gravity and time. moving not just through the universe but within it, woven into its fabric, drawn by its tides, part of its unending hunger and its endless creation. For all its collisions, tides, and hidden currents, the Milky Way is not merely a drifting sea of stars, it's a living system with a beating heart. Deep in its center, past the dust and dark lanes of its spiral arms, lies an intricate engine of motion that shapes the entire galaxy's destiny. For decades, astronomers suspected that our galactic heart might hide one of the universe's most common yet mysterious features, a central bar. In most spiral galaxies, such bars appear as bright bridges of stars, stretching outward from the nucleus, long, glowing handles that seem to turn the galaxy's inner machinery. They serve as gravitational conduits, channeling gas and dust inward toward the core, feeding bursts of star formation and stirring the patterns that sculpt the spiral arms. But for the Milky Way, the question remained unsettled for generations. We simply couldn't see. From our position embedded within the galactic disk, the view toward the center is like staring through miles of fog with a single candle. Clouds of interstellar dust, dense and light-absorbing, block visible light almost entirely. To map the Milky Way's architecture from inside it is like trying to understand the layout of a forest while lost among its trees. You see trunks and branches, but never the shape of the whole. That veil of obscuration held until the early years of this century. Then, in 2005, the Spitzer Space Telescope turned its gaze toward the heart of our galaxy, not with ordinary light, but with infrared vision, a form of light that can slip through dust, like warmth passing through fog. Suddenly, the darkness began to thin. Through that invisible spectrum, astronomers could finally glimpse what had been hidden for so long. What they saw changed everything. Stretching roughly 27,000 light-years across the core, they found an elongated river of stars, a vast galactic bar rotating as a single, solid body. Billions of suns form this luminous bridge, spinning around the central black hole like a great cosmic handle. It is not static, it twists and turns, carrying material inward and outward in a gravitational dance that helps define the very shape of our galaxy. The existence of this bar solved several long-standing puzzles. It explained why our spiral arms form the way they do, why they seem to flow from certain directions rather than radiate uniformly from the center. The bar's gravity acts like a stirrer, creating waves of compression that sweep outward through the disk, squeezing clouds of gas until they collapse to form new stars. It also channels gas toward the galactic nucleus, where the central black hole occasionally awakens to feed, glowing briefly before returning to silence. This bar, too, is in motion. It completes one full rotation roughly every few 100 million years, faster than our sun's orbit around the center, so every so often, our solar system drifts into alignment with its gravitational influence. When that happens, waves of star formation ripple through nearby regions, lighting up the spiral arms like city lights, turning on at dusk. Over cosmic time, the bar itself evolves. As it transfers angular momentum to the disk, it slowly lengthens and strengthens, a living structure that grows more prominent as the galaxy ages. Simulations suggest it formed relatively recently, within the last few billion years, proof that even a galaxy can reinvent its own heart. This realization transformed how astronomers picture our home. The Milky Way is not a simple spiral with a round bulge in the middle. It is a barred spiral, complex and dynamic, with its inner regions constantly reshaped by gravitational feedback. The bar is both engine and architect, driving the flows of matter, that sustain the galaxy's slow rhythm of birth and decay. Across the Milky Way, that rhythm continues unbroken. At any given moment, about 3 new stars ignite, while 2 others die. A steady cycle that has persisted for more than 10 billion years. Through this quiet arithmetic, hydrogen and helium, the universe's first and simplest ingredients, are transformed into heavier elements. Carbon, oxygen, iron, and the countless atoms that form planets, oceans, and living beings. Every element in your body, except hydrogen, was forged in the heart of a star, born in the nuclear furnaces that burned long before Earth existed. But these births do not happen everywhere at once. Star formation thrives in the spiral arms, where waves of density, driven in part by the bar, compress the clouds of gas that float through the galactic disk. Inside those clouds, gravity takes over. Regions collapse inward until the pressure grows fierce enough to ignite fusion and new stars flare to life. These star-forming nurseries glow brilliantly, filling the spiral arms with the blue light of young, massive suns. They are the bright stitches that make spiral galaxies visible even from across billions of light years. The heaviest of these newborn stars, 10 to 100 times the mass of our Sun, live fast and die violently. In only a few million years, a heartbeat by galactic standards, they exhaust their nuclear fuel and collapse, exploding as supernovas. In those few seconds of fury, they release more energy than our Sun will in 10 billion years. Their shock waves race through nearby gas clouds, compressing them further and triggering new rounds of star formation. Destruction gives birth to creation, again and again, in a self-sustaining cycle that has shaped the Milky Way's evolution for eons. Smaller stars, like our own, live quieter lives. They burn their fuel slowly, lasting billions of years, offering steady warmth to any worlds that orbit them. When their time comes, they expand into red giants, shedding outer layers of gas into space, before contracting into dense white dwarfs, fading embers that can persist for trillions of years. These long-lived stars are cosmic caretakers, providing the stability needed for life to emerge and evolve. The chemistry of each generation of stars changes the galaxy itself. The very first stars formed from the universe's purest materials, only hydrogen and helium, left over from the Big Bang. When they died, their supernovae seeded space with heavier elements. New stars formed from that enriched gas, carrying within them the raw ingredients for planets, minerals, and, eventually, living cells. Each cycle added complexity, building the periodic table one stellar death at a time. Our Sun is one of those later children, a third-generation star, born about 4.5 billion years ago from material that had already passed through countless previous lives. The calcium in your bones, the iron in your blood, the gold in your jewelry, all were once part of other stars, scattered through the galaxy before being gathered again into this solar system. You are, quite literally, recycled starlight. Star formation has slowed since the Milky Way's youth. Around 10 billion years ago, the galaxy blazed with activity, birthing new suns at a rate 10 times higher than today. But as the available gas was consumed or locked away in long-lived stars, the pace of creation diminished. The galaxy is still alive, still forming stars, but its vigor has settled into something calmer, an older rhythm, quieter but enduring. And yet, even this slowing heartbeat carries a kind of grace. The bar continues to rotate, the arms continue to breathe, and the galaxy keeps transmuting matter into meaning. In every corner of the Milky Way, from the central bar to the faintest edges of its spiral arms, stars are being born, living their radiant lives and dying to make way for others. It is a continuous story, a cosmic metabolism, and we are one of its smallest, briefest thoughts, alive for a moment within the luminous body of the galaxy that made us. The Milky Way, for all its restlessness and change, still has many long nights ahead of it. The galaxy continues to breathe slowly, deeply, through the cycle of star birth and death that has defined its life for over 10 billion years. Computer simulations suggest this rhythm will continue for billions more, though each breath will grow shallower with time. The gas and dust that feed new stars are finite. Every supernova that enriches the galaxy also locks matter away in remnants, white dwarfs, and black holes. Someday, far in the future, the Milky Way's fires will fade, and its last stars will form from the final whispers of cosmic gas. The galaxy will not die suddenly, it will simply grow quiet, its brilliance dimming to embers as the stellar furnaces go out one by one. But even as its light will one day fade, the shape of the Milky Way continues to surprise us. For much of the last century, astronomers believed our galaxy had a clear, solid edge, a disk roughly 50,000 light-years in radius, beyond which lay only a scattering of lonely globular clusters and the occasional drifting star. The Milky Way, they thought, had boundaries as certain as the horizon. Then came the revelations. In 2018, using exquisitely detailed data from the Gaia Space Observatory, astronomers discovered something startling: stars belonging to the galactic disk far beyond that supposed limit, reaching out to 84, even 100,000 light-years from the center. And that wasn't the end of it. Later studies found stars stretching even farther, up to 130,000 light-years away. The edge we thought existed was no edge at all. Our galaxy's body extends tens of thousands of light-years beyond the map, like the faint outer glow of a lantern that had always been there, just too soft for us to see. This discovery reshaped our sense of cosmic scale. The Milky Way isn't a tidy pinwheel ending in clean symmetry. It's a sprawling, diffuse organism, its outer disk flaring and warping, its stars thinning into the dark like breath fading into cold air. And still, the stellar disk is only a fraction of the whole. Surrounding it, nearly 2 million light-years across, is the invisible halo of dark matter, the true skeleton of our galaxy, holding everything in place with gravity alone. This means the Milky Way's reach extends almost halfway to Andromeda. If Andromeda's halo stretches as far as ours, then the two have already begun to touch. In a sense, the collision we imagine billions of years from now has already started, not with stars colliding, but with invisible matter brushing against invisible matter, their gravity quietly mingling in the space between. How such an enormous structure holds together remains an open question. The stars in the outermost regions take 1 billion years to complete a single orbit. Some have circled the galaxy only a handful of times since its birth. Their presence challenges our understanding of stability and balance. Perhaps they are remnants of smaller galaxies, pulled apart by our gravity, their stars scattered into vast, faint streams. These rivers of light, remnants of ancient mergers, may account for much of the distant population now known to belong to the Milky Way's extended disk. Each new observation pushes the boundaries outward again. Every time technology sharpens our view, new telescopes, better detectors, more sensitive instruments, we find more stars, more structures, more of ourselves. It's as if our galaxy is perpetually revealing another layer of its story, a horizon that refuses to stay still. Maybe the Milky Way's true size is not something that can ever be precisely measured. only approached as if we are forever walking toward a line that keeps receding. And yet, beyond the light and matter, there is another architecture at work, one we cannot see, but that threads through everything like the veins of an unseen organism. Magnetic fields, delicate yet powerful, spiral through the Milky Way's body, tracing paths that extend across its entire 100,000 light-year width. These fields are unimaginably weak, thousands of times fainter than the magnet on your refrigerator, but they shape the galaxy in ways that are profound and subtle. Invisible magnetic highways carry streams of charged particles across space, guiding the flow of energy through the interstellar medium. Cosmic rays, high-energy protons and electrons born in the explosions of dying stars race along these lines, spiraling through the galaxy for thousands of years before finding rest. The fields themselves twist around the spiral arms, coiling in graceful curves that mirror the Milky Way's luminous shape. This alignment isn't coincidence. As the galaxy rotates, its motion stretches and winds its magnetic field, like threads twisted in a spinning wheel. Over millions of years, the rotation organizes chaos, turning turbulence into structure. The field becomes a quiet force, intangible, invisible, yet woven into the dynamics of everything from star formation to cosmic weather. Inside the dense clouds where stars are born, magnetic fields act as both restraint and midwife. They push back against gravity, delaying collapse until the balance of forces tips and the gas gives way. In some regions, tangled fields slow star birth. In others, compression strengthens them, hastening it. Every newborn star, every glowing nebula, carries the fingerprint of these hidden forces. Recently, we have begun to glimpse the shape of this magnetic web in detail. The Planck spacecraft, launched by the European Space Agency, mapped the polarization of light emitted by interstellar dust. Because those dust grains align with local magnetic fields, their polarized light reveals direction, like iron filings tracing the lines around an unseen magnet. The resulting maps show a breathtaking complexity. A galaxy threaded with filaments, arcs, and loops of magnetic energy. An invisible scaffold surrounding every visible structure we know. These fields arise naturally from motion. As vast clouds of ionized gas drift and spin through space, they generate electric currents that in turn produce magnetic fields, a cosmic dynamo operating across the galaxy's body. The Milky Way's rotation amplifies these currents, twisting and folding the field into enormous, ordered spirals that girdle the disk. Their strength varies dramatically from place to place. Near the galactic center, where stars are dense and the supermassive black hole churns, the magnetic fields grow hundreds of times stronger than average. Out in the quiet regions between spiral arms, the fields weaken, barely influencing the charged particles that roam there. But when these fields snap and reconnect, events known as magnetic reconnection, they release enormous amounts of energy, sometimes enough to heat entire regions of interstellar space. Magnetic fields are the galaxy's nervous system, subtle, pervasive, endlessly active. They carry information and energy across distances too vast for light alone to shape. They link the Milky Way's visible structure to the broader electromagnetic web of the universe, binding the movements of dust and plasma to the deep, invisible geometry of space-time itself. From the outermost halo of faint stars to the smallest currents of charged gas, every part of the Milky Way is connected through these threads. Our galaxy is not just a collection of stars. It is an intricate organism of light, gravity, and magnetism, alive with motion. And though we see only fragments of it from our small vantage point, every night sky is a reminder that we are inside that living system, woven into its quiet electric pulse, carried along its magnetic breath through the endless dark. Even the most delicate structures within our galaxy, the magnetic filaments, the spiral arms, the glowing nurseries of newborn stars, belong to something larger still. The Milky Way, for all its majesty, is but one thread woven into a tapestry too vast for imagination to easily grasp. We are not unique in kind, only in our nearness to ourselves. Beyond the quiet edges of our galactic disk, beyond the faint reach of our halo, stretches a cosmos so populated that our entire galaxy becomes a single note in a symphony of unimaginable scale. Astronomers now estimate that the observable universe, just the portion we can detect, contains roughly 2 trillion galaxies. 2 trillion islands of light, each with their own billions or trillions of stars, their own worlds, their own mysteries. It is a number so large it resists comprehension. Even if you could count one galaxy every second, day and night, you would still be counting long after the sun and earth were gone. Against such vastness, the Milky Way, our home of 400 billion stars, amounts to less than a trillionth of the total. And in many ways, we are ordinary. Our galaxy sits near the middle of the galactic scale, neither among the smallest dwarfs, nor the great ellipticals that can contain over 1 trillion stars. Roughly 60% of all galaxies are spirals like ours, adorned with winding arms and central bulges, flattened into cosmic disks by rotation. The Milky Way is one among billions of these familiar shapes, a citizen of a common class in a universe of near-endless repetition. Yet even in the ordinary, there is room for distinction. We happen to live in a quieter corner of the cosmos. Many galaxies inhabit crowded clusters where collisions and mergers are frequent, their shapes constantly torn apart and remade. Ours, by contrast, drifts in a relatively calm pocket of space. We have companions, the Magellanic Clouds, Andromeda, but our neighborhood is sparsely populated, allowing our spiral structure to endure for billions of years with minimal disruption. This cosmic solitude may be part of what allowed our galaxy, and perhaps life within it, to remain stable long enough for complexity to arise. Chemically too, the Milky Way is unremarkable in a comforting way. Its stars contain typical proportions of heavy elements: carbon, oxygen, iron built up through cycles of stellar death and rebirth. Our sun's metallicity, slightly higher than average, marks it as a latecomer in this long process, born from the ashes of generations of earlier stars. Across the universe, other spiral galaxies show similar patterns, shining with comparable colors and forming stars at similar rates. Astronomers place our galaxy within what they call the Green Valley, a transitional state between vigorous youth and quiet age. Star formation continues, but more slowly now, as the reservoir of gas thins. The Milky Way is neither a newborn blue spiral, nor a retired red elliptical. It rests somewhere in between, its activity fading with dignity rather than drama. In the language of galaxies, we are middle-aged, still luminous, still changing, but aware that the days of youthful intensity are behind us. To think of 2 trillion other galaxies, each with its own suns, planets, and perhaps life, is to confront both our insignificance and our connection to everything. Every one of those distant galaxies is a mirror, showing that what we call our universe is not a singular home, but a community of homes, each different, each the same. The thought does not make us small. It simply places us among the multitude. But these galaxies, too, are not scattered randomly. They follow a deeper order, drawn into patterns shaped by the universe's invisible architecture. The Milky Way is not adrift in emptiness. It travels along one of the filaments of the cosmic web, the largest structure known. This web is the universe's skeleton, a lattice of dark matter stretching across billions of light years, binding galaxies together with gravity's unseen hand. These filaments are not thin or fragile. They are vast bridges connecting clusters of galaxies, like the beams of a cosmic scaffolding. Between them lie enormous voids, immense, nearly empty spaces where matter is scarce and silence reigns. Through these filaments flow the materials of creation: hydrogen gas, dark matter, and energy. About 60% of all matter in existence lies within them. They are the arteries of the cosmos, carrying matter toward the dense nodes where thousands of galaxies converge. In maps of the universe made by powerful telescopes and computer simulations, these filaments resemble the branching tendrils of a neural network, a cosmic brain where galaxies flicker, like neurons firing across incomprehensible distances. Our own galaxy moves along one of these strands, its path determined by ancient gravitational currents set in motion shortly after the Big Bang. Like a train gliding along invisible rails, the Milky Way follows a route defined by the distribution of dark matter that formed when the universe was young. Every turn we make, every slow drift through space, follows a map written in gravity long before our sun ever existed. The filament we inhabit connects our local group, the Milky Way, Andromeda, and their smaller companions to the Virgo cluster, a massive congregation of over 1,300 galaxies, 54 million light-years away. It is one of the many highways of the cosmic web, and it serves as the gravitational framework that directs our motion. On this scale, even galaxies are travelers, flowing like droplets of light along the great filaments that link them to others. Within these filaments lies more than stars. They contain enormous reservoirs of hot, ionized gas, heated to millions of degrees, glowing faintly in X-ray light. This gas forms the intergalactic medium, a diffuse plasma that fills the spaces between galaxies. It is both the ashes of dead stars and the raw material for new ones, a cosmic bloodstream nourishing creation on the grandest scale. Astronomers have only recently begun to trace these structures directly. Using instruments capable of detecting X-rays and subtle distortions in light called gravitational lensing, scientists have mapped the first outlines of the web. The results confirm what theory predicted. Our galaxy, our cluster, and even the Great Attractor itself are all part of this interconnected network, drifting within the largest architecture the universe has ever built. So when we imagine the Milky Way sailing through the dark, it is not moving alone, it is gliding along a filament of the universe's very framework. Every atom, every star, every orbit in our galaxy participates in that motion. The cosmic web stretches in all directions, binding galaxies like pearls on invisible strings, connecting everything to everything else. In this way, our home is not just a galaxy among trillions, it is a thread in the living fabric of the cosmos, woven into a structure so immense that even the speed of light takes eons to cross from one end to another. The Milky Way, with all its stars and stories, travels as part of this grand design, carried along a filament that began forming long before any eye, human or otherwise, could look up and wonder where it was headed. Even here, at the outermost threads of comprehension, the Milky Way is not alone. The cosmic web that cradles us continues to shape what we are becoming. It governs the quiet exchange of matter between galaxies and the vast intergalactic sea, feeding and sculpting our spiral home in ways both subtle and profound. Streams of gas drift inward along the filaments, flowing like invisible rivers through the dark. That gas becomes the raw material for new stars, the same substance that once formed the sun, the earth, and the atoms in our own blood. At the same time, our galaxy breathes outward. Winds from supernova explosions and radiation from young stars blow streams of material back into intergalactic space. The Milky Way exhales what it has created, returning energy and matter to the very filaments that once nourished it. Through this grand exchange, our galaxy remains part of a cosmic metabolism. It takes in, it gives back, and in doing so it participates in the slow, endless evolution of the universe. Every star that forms, every element released by a dying sun, and every gust of galactic wind becomes part of the great circulation of creation that flows through the cosmic web. The Milky Way is not an isolated island of light. It is a living cell within the greater body of the universe. And yet, for all our knowledge, we can never see this home of ours as an outsider might. If we could somehow leave, if we could sail beyond the farthest reaches of our dark matter halo and look back, we would behold one of the most breathtaking sights in existence. Against the velvet dark, the Milky Way would unfurl as a vast, luminous spiral, its arms curving outward like brushstrokes of light across the void. Billions of stars would shimmer in sweeping arcs, their collective glow revealing the elegant symmetry of the structure that holds us. Along those arms, clusters of newborn blue stars would sparkle like scattered jewels, their brilliance tracing the paths of the spiral density waves that give the galaxy its shape. Between them, a softer gold would dominate the light of older stars, quieter and steadier, weaving warmth between the bright lanes of youth. Across the center, the bar-shaped heart of the galaxy would glow with the accumulated fire of ancient suns, slowly rotating around the invisible presence of the supermassive black hole, Sagittarius A*. Dark threads of dust would wind through the light, etching rivers of shadow into the galactic disk. These lanes, beautiful and opaque, would mark the sites where future generations of stars wait to be born. Beyond the luminous spiral, a faint halo of globular clusters would shimmer like lanterns. At the edge of the night, ancient colonies of stars that predate our sun by billions of years. Their orbits would trace the invisible geometry of the galaxy's three-dimensional form, flickering around it like fireflies circling an unseen flame. The dark matter halo, our galaxy's unseen skeleton, would remain invisible even from this godlike perspective, perceptible only through its gravitational signature, the silent grip that holds every star in place. Viewed from the side, the Milky Way would appear impossibly thin, a radiant disk with a thickness less than 1/50th of its width. Its outer rim would bend gently, upward and downward, a slow cosmic warp, like a spinning coin beginning to wobble before it comes to rest. Around this shining disk, smaller galaxies, the Magellanic Clouds, the Sagittarius Dwarf, and others, would drift like attendants, their shapes stretched and torn by our galaxy's tidal embrace. Trails of stolen stars would arc gracefully across the dark, forming bridges of light that testify to eons of gravitational dance and quiet destruction. Far beyond, the Andromeda Galaxy would hover in the distance, another grand spiral, its arms faintly glowing across the abyss. It would appear almost close enough to touch, a future partner on a slow collision course. In 4 billion years, the two will merge, their shapes dissolving into a single new galaxy, a luminous sphere born from the union of two spirals. But that vision, the view from the outside, will never belong to us. We live inside the cathedral, not beyond it. We see the pillars, the arches, the filtered light through the dusted windows of our sky. But we can never step outside to see the entire design. Our perspective is bounded by the very structure we seek to understand. Like explorers confined within the walls of an immense and ancient temple, we map what we can, infer the rest, and fill the unknown spaces with imagination and wonder. Still, what a triumph it is that, from our tiny corner of one spiral arm, we have learned to trace the architecture of this vast home. Through patient observation, through the language of mathematics and the poetry of physics, we have pieced together an image of the galaxy that made us. We now know that the Milky Way spans more than 100,000 light-years, holds hundreds of billions of stars, and moves as part of an immense web that connects it to all other galaxies in the universe. We have never seen our galaxy as a whole, and yet we know its heart beats with light, its arms shimmer with creation, and its edges breathe into the cosmic dark. To study it is to study ourselves, for every atom in our bodies was once part of its story, born from stars that lived and died within this spiral sea. And so we remain here, suspended within its vastness, turning slowly through space with the quiet certainty of belonging. Our galaxy is both our origin and our vessel, our history and our horizon. We are, and always will be, children of the Milky Way, tiny sparks of consciousness drifting within a greater light, forever trying to understand the luminous home that carries us through the infinite night.